2010 number 1 with a graphing calculator. Oh my gosh, are you excited to see this problem again? Here we go. Part A, how many cubic feet of snow have accumulated on the driveway by 6 a.m.? Now this is the piece of this problem that I took out of the question the past year that we've worked on this and done this over and over. F of t is the rate that snow is accumulating on the driveway in cubic feet per hour. The big thing here, F and G are two functions that are rates because they are measured cubic feet per hour. So for part A, how much snow has accumulated? I want to add up all the snow that has fallen by 6 a.m. So I'm adding up, integrating from 0 to 6 a.m. the rate at which it's accumulating. So I'm integrating F of t. Put it on my calculator. I'm going to put F of t, I'm putting that equation into y1. Be careful, make sure your exponent is in parentheses if you have an older version of the calculator. So I integrate from 0 to 6, I get my answer, 3 decimal places, it's cubic feet, and you're done. Part B, find the rate of change of the volume of snow on the driveway at 8 a.m. Rate of change. We are given the rates. The volume of the snow on the driveway at 8. You have to think about how much snow has fallen and how much snow has been shoveled. That's the big thing with part B. So when we look at this, the volume is the snowfall minus the snow that's been shoveled. And since we want rates, I have the rates. F is a rate, G is a rate. So I'm going to find how much snow has fallen at 8, that's F of 8, minus how much snow has been shoveled, that's G of 8. So I evaluate that, and this is my answer. What this means, the rate of change of volume is negative because at 8 o'clock you are shoveling, or Janet is shoveling faster than the snow is falling. So make sure you're rounding to the proper 3 decimal places and you have your units there, okay? So this is the big thing. Because we want rate of change of volume, you're just subtracting the rates because we were given the rates, okay? Now, part C. This is the key. You have done this many times. Let H of t represent the total amount of snow in cubic feet that Janet's removed from the driveway. Express H as a piecewise defined function with a domain of 0 to 9. I hope we get this right. Part C, here's our traditional piecewise model. How much snow has been removed from the driveway from 0 to 9. No shoveling is done from 0 to 6. I take the previous amount plus the rate times how much time has she been shoveling. This should look super, super familiar. And then that's from 6 to 7, and then from 7 to 9, she's slowing down. So 125, that's the total from the previous piece of my function, plus 108 times t minus 7, because those 7 hours are accounted for in this number right here. So that should be pretty straightforward. That's what I've had you do the past year, okay? Part D, how many cubic feet of snow are on the driveway at 9 a.m.? Again, you have to think about all the snow that's fallen and how much has been removed. So here we go. For part D, I want to find out all the snow that's falling. So I'm going to add up all the snow that falls between 0 and 9. So integrate F of t from 0 to 9. Get that straight on the calculator. Minus how much has been removed. Well, this right here, 125 plus 108 times 9 minus 7, that's using your piecewise function. That's just you finding H of 9. So H of 9 means you'd be using the last piece here. You're subbing a 9 in for t. Sub that in, you get 341. That number should sound familiar. Subtract them. That's your final answer. Hope you enjoyed it.